Welcome to a short video on the business implications of capability studies. The video will cover the basics of capability calculations, standard metrics that are in use for capability, and implications of tracking capability. That means what benefits can be achieved by appropriate and timely actions if you track capability. Process capability means the ability of the process to meet specifications as described by customer or designer. The ratio of variation that customer allows, also called tolerance, and the variation which actually happens in the process is basically process capability. So for example, let us take if upper specification limit is 55, lower specification limit is 35, the tolerance is 55 minus 35, which is 20. If the process varies between 36 and 54, which means the lower control limit. Control is different from specification, that we all know, and the upper control limit is 54. The overall natural process variation is 54 minus 36, which is 18. And therefore, the process capability, which is denoted by CP, is the ratio of tolerance and process variation, and therefore it is 20 divided by 18 and is equal to 1.11. We can see since the process capability is more than 1 and therefore the specification appear outside the control limits, and therefore process is producing very minuscule defects. However, this definition has a minor flaw, or we can see there is a scope for improvement, as it cannot capture the process mean shifts from the target. So when the process is, average is shifting from the target value, this is not able to capture. As we can see in this process, the process mean is has shifted from 248 from the target value of 45, which has resulted into increase in defects higher than upper specification limit. However, the traditional measure of process capability, which is CP, shows the same value, which is 1.11. However, the value was expected to reduce. Accordingly, a new metric called process capability index is used, which captures both process variation and shift in mean. So process capability captures process variation but is insensitive to process shift, whereas process capability index is sensitive to both process variation and shift in mean. Please refer to the picture shown, where A is the distance between the mean and the nearest specification. Here in this case, the nearest specification, upper specification limit, where B is the distance of the mean from the corresponding control limit. So if we are measuring with reference to upper specification limit, we will measure with respect to upper control limit. So if we see in terms of numbers, A is equal to U upper specification limit minus mean, which is 55 minus 48, which is equal to 7, and B is upper control limit minus mean, which is 57 minus 48 and is equal to 9. Therefore, CPK is A by B, which is 7 by 9 and is equal to 0.78. The value is less than 1, which clearly indicates the defects have increased. So we can see this this measure, which is called process capability index, is able to capture both mechanisms of defect increase, which is shift in mean from the target value, and increase in process variation. Now let us learn about some capability metrics, and specifically short-term capability and long-term capability. So when we collect data for consecutive parts, or we can say continuously for any output, for a very short period of time, most of the input parameters can be assumed to be constant. Therefore, the variation is expected to be minimum in output parameter. And when we try to calculate capability based on this short period of time, it represents actually the design or best possible capability, and is represented by CPK, and also called as process capability index, which we learned just now. However, when we keep on collecting this short-term data for a very long period of time, for example, we collected 10 parts, measured it, and then after maybe next day again we collected 10 parts and 10 consecutive parts and measured the short-term capability. This we keep on doing for several days, for let us say for 30 days. In these 30 days, we are able to capture variation for several reasons. For example, like batch change, shift change, or temperature changes, or any other changes which are possible. When now for this long period, we calculate variation. The variation is expected to be higher, and actually what variation the customer is going to see. And when we measure our capability using this variation over a long period, for example a month, the this represents actual process performance and therefore is called as process performance index. Calculation is similar to CPK, but it is now called as PPK. So we have learned two terms, CPK and PPK. Same way, if you do CP calculation for if you do calculation of CP for a short period of time, process capability, it is called as process capability, and when you do it for a long term, it is called as process performance. The most common question that we hear from business leaders is, what are the recommended values of process capability index? So the most of the companies have accepted these recommendations is that most of the product characteristics and key consumption characteristics should have capability index more than 1. On other hand, all important product characteristics, usually where they are non-reworkable and can be classified as significant characteristics, should have capability index of more than 1.33. And finally, all safety and regulatory related characteristics should have capability index more than 1.67. Most important part of capability studies is our ability to continuously track and take action. For example, whenever capability is going on lower side, you will see the defects are increasing. Sometimes if companies are not transparently reporting defects, you will see the planned production volumes are increasing. For example, if the order is for 100, we will try to produce 120. Also, we will see the consumptions of raw materials of critical utilities is increasing. Whenever capability goes down, that means your consumption ratios are adversely affected. Also, because of these disruptions, we start piling up inventory to in anticipation if there is some problem, we will still be able to meet orders. So you will see with lower capabilities, higher defects, higher planning volumes, increased consumptions, and very high inventory. So these issues can be actively addressed by a good knowledge on statistical process control. We have a good course on SPC as a SPC expert course. We strongly recommend for the people who are interested in improving their capabilities. They can contact our email on through our email training@qultima.com or go to our website www.qultima.org. On other hand, when higher process capability is a good news, it also need action to convert into business gain. For example, when we have very near zero defects because the capability has increased, management has to consider reducing inspection. That means inspection costs can be reduced. They can also think of direct online suppliers, where since the capability of the suppliers is very high, we can directly ask them directly to supply on the line, and therefore think in terms of significant reduction in terms of logistics and inventory costs. Same way, when the capability is increasing, we should keep on reducing allowances, or for example in production volume some allowances are taken. We should ask why we are taking such allowances when the process capability is increasing. Same way, when the capability of the consumption parameters are increasing, we will have to work on adjusting capability itself to get the gains. So also, since the disruption possibilities are reducing, we will have to keep on reducing inventory in view of improved capability. The key similarity between The low and high capabilities is that both require management action for business gains. So action is required, and therefore we need knowledge of SPC tools. When capability is low, take action to avoid problems. When capability is high, take action to convert advantageous positions into business gains. Thank you.